Okay, there's another way of actually testing for significance. Instead of using the t-test, you could also use the f-test. So it's based off of the ANOVA, the analysis of variance, which we skipped over that chapter. Not that it's not important, it is very important, but there's just a time constraint in this course. So if we look at this, this is an ANOVA table. So actually when we do our regression, you are going to see this output, so I want you to be aware of it. So you notice a lot of this we already talked about, the sources of variation. Right? It can be due to regression, error, and total, right? And we talked about the sum of squares, right? The total is equal to the error plus the regression. We already talked about that. The degrees of freedom, we already talked about that for the sum of squares. Sorry, this keeps going back. Errors, right? It's equal to n minus 2. The total is equal to the sample size minus 1, and for regression, sorry, I don't know why this keeps changing, is just equal to 1. So the thing about these these two columns here is that they sum to the total. So the regression plus error we already know is equal to the total. Well, it's the same thing for the degrees of freedom. So what is n? N is our sample size. We have 10. So 10 minus 2 is 8. 8 plus 1 is 9. Well, our sample size of 10 minus 1 is 9. So these degrees of freedom should add up to the total, just like the regression and error sum of squares add to this total sum of squares. In terms of the F statistic, so just like we have a T statistic, which is equal to, right, our B1 minus B0, right, divided by SB1, right, our F is also has a value that gets estimated, and then just like a T distribution has its own distribution, the F-test, right, it has its own F distribution, which you can then use to calculate the p-value. So it's a slightly different approach, but you'll get the same answer as you get with the t-test for a simple linear regression. So we already solved for the mean square. We already solved this. We already know that it's equal to the sum of squares error divided by its degrees of freedom, which is just n minus 2. Why 2? Because there are two parameters that we're estimating, the intercept and the slope. For the MSR, right, that's the mean squared regression, is just equal to the sum of squared regression divided by 1. Why 1? Because it represents the number of independent variables. When we only have one, we just have the one x. That's a simple regression, right? Just one predictor variable. So if we divide those, we get our F statistic. So if we look at the pizza example, right, we already have these values. We calculated the degrees of freedom already. We already calculated the mean square error. So this is the mean squared for the regression. And if we just divide those, we get our F statistic. And that's very large as well, so it is also significant. So I just want you to be aware of this approach. I'm not going to go through all the math because honestly a lot of it is very similar to when we've already calculated most of these values anyway, and it will also show in the Excel output. In fact, it will show up in typically any or most output regardless of what software you use. So it's good to be aware of it in terms of like when you see the F, what does it mean, right, the degrees of freedom, all this stuff. At least now you know where it comes from.